Let's move on to wave and tidal energy. The ranking here is by 2050, 29 is the ranking. The reduced CO2 is estimated at 9.2 gigatons. Net cost is $411.8 billion, with net savings of -1 trillion in total net savings by 2050. This is one of the technologies that is used. You can see it's taking in wave energy. It could be tide, it could be waves, and there are various technologies like floating ones, fixed ones, compressing air, and so on. There are estimates of wave energy. So there is tide energy, there is wave energy, not exactly the same. Waves are generated by winds, where tides are generated by gravitational attraction of the moon and the sun. Moon obviously dominating because it's much closer, and wave energy is proportional to tides are proportional to 1 over r cubed, the distance between Earth's center of mass and moon. So the average annual power in kilowatt per meter, you can see in the mid-latitude, westerlies, and the southern latitudes, they are very high, from 30 onwards to greater than 60 in some hotspots. And some of these countries here have good potential for wave energy. Australia, and so on. The tidal range resources available worldwide, again you get high concentrations here, up here, in the Canadian regions of Iceland, Greenland, and again Northern Europe, and so on, and even regions like India have decent potential for tidal range if they wanted to harvest that. They don't have much in terms of waves. It's fairly low here, but this also means there is an opportunity to develop methods that can harvest low amplitudes of waves. Wave energy basically goes as wave height squared. That's the kinetic energy of the waves. This is just a quick look at the various technologies classified here into the oscillating water column, which was designed by a Japanese naval engineer, I think. Basically, it's about the air that's coming in and compressing the water that's coming in, compressing the air, driving a turbine, and then it's expanding and driving the turbine again. So it could be a fixed structure, or it could be a floating with evocative names like Mighty Whale, Ocean Energy, Superboy, and Ocean Lynx being the companies that are involved in these technologies. Oscillating bodies with hydraulic motor, hydraulic turbine, linear electric generator, again floating or submerged, and overtopping with low head hydraulic turbine, which also have fixed structures and floating structures with concentration, things like wave dragon. So when people are putting up wave and tidal energy infrastructure, there are concerns for aesthetics. People who want to live near the water or visit the waterfront don't want to see these things blocking the view or spoiling the view, and so they are sometimes put underwater, but they are also could be hazard for fishermen who are operating in those waters. So these submerged technologies here, vertical and horizontal turbines, enclosed turbines, and hydrofoil designs, and so on. So there is room for innovation over there should you be interested in exploiting wave and tidal energies as renewable sources. As long there is sun shining and as long there is moon's gravity, we are going to have wave energy somewhere. Mid-latitude westerlies are not going to disappear anytime soon. There could be changes in other regions where wind strength can change. For example, monsoonal circulation may weaken with global warming, with the ocean warming, relative ocean land warming, and so on. So those things have to be planned just like for onshore and offshore wind energies. This is an estimated ocean power generation scenario from the International Energy Agency for 2000 to 2030. You can see that the numbers are fairly low and have remained fairly flat, with a slight increase here around 2012 or so in terms of terawatt hours. Somehow the projections are quite bullish in terms of the numbers going up almost an order of magnitude from less than 2 to 16 by 2030. Okay. Just to conclude this very short look at the wave and tidal energy, there are not many projections of wave and tidal energy to 2050. Right? This is the one to 2030. Building on those few, we estimate that wave and tidal energy can grow from 0.004% of global electricity production to 0.28% by 2050. The result, reducing carbon dioxide emissions by 9.2 gigatons over 30 years. Cost to implement would be $412 billion, with net losses of $1 trillion over 3 decades. But the investment would pave the way for longer-term expansion and emissions reduction. So I guess the cost and the net losses will depend on how the externalities of reducing emissions and their contribution to reducing carbon dioxide is accounted for. But if it leaves a prospect for the future, it could be worth it. And wave energy has been actually exploited for centuries, and yet it doesn't contribute at a large scale to the renewable portfolio of any country, other than few that have consistently exploited them, like Netherlands and the UK and maybe Sweden and so on. Okay, so I'll leave it there. I hope I haven't made a mistake about these net costs and losses. Yeah, the net savings here is negative, actually means net losses. I might have said it wrong before. I hope not. Okay, just remember that. Let's leave it here.